In this video we're going to look at solving trig equations. Let's imagine we've been asked to solve the equation 4 sine x degrees subtract 1 equals 0. And it would give us like a domain. It would tell us that x would be in between 0 and 360 degrees. Okay, so in order to solve these problems we need to have knowledge of our cast diagram. In the first quadrant all the trig functions are positive, in the second quadrant only sine is positive, in the third quadrant only tan is positive, in the fourth quadrant only cos is positive. These are derived from the trig graphs, each individual trig graph, and if we were to split each trig graph into 4 equal quarters, in the first quarter of each trig graph all of them are above the x-axis. In the second quarter, only sine is positive, only sine is above the x-axis. Both the other tan and cos are below. In the third quarter, only tan is above the x-axis, only tan is positive. And in the fourth quarter, the final quarter, only cos is positive. And by splitting up our 360 degrees, because the trig functions we see are within 360 degrees, if we split them into quarters, they would go up in multiples of 90. So it goes 0 to 90, 180, 270, and then it would cycle back to 360 degrees. Okay, that's roughly where we are getting our cast diagram, as it is sometimes referred to as. Okay, so we have been asked to solve 4 sine x degrees subtract 1 equal to 0. If our question was solve 4x minus 1 equals 0, we would add 1 to both sides and divide by 4. What we're going to do is we're just going to treat sine x like any other variable. So we're going to add 1 to both sides. 4 sine x equals 1. Divide through it by 4. Sine x equals 1 quarter. Okay, so this is a point where we have to pause. At this moment I have got sine x equal to 1 over 4. That essentially corresponds to sine x being positive. So from this part here we need to look to our cast diagram. We need to look for the points where sine is positive. We need to look for the quadrants where sine is positive. So in quadrant 1 all of the functions are positive. In quadrant 2 sine is positive. So I can tick 2 quadrants. When you're doing these you'll always be ticking 2 quadrants. Okay, so what we're going to do now is we are going to need to find our acute angle and then our related angles. So to find our acute angle, to solve for x we need to do the inverse sine of 1 quarter. So if we do that in our calculators, shift sine of a quarter, we will get to an answer of 14 degrees. What this corresponds to, if I'm going to draw this again, our angles are always in relation to the horizontal line. So 0, 90, 180, 270, 360. So our answers are in the first and second quadrant. So it's going to be this angle in here that we are interested in, and this angle here they were interested in. We always read the cast diagram in an anti-clockwise fashion. Okay, so our related angles, therefore, so the first one can be found in quadrant 1, and the first angle simply is 14 degrees. In quadrant 2, we know that this little angle in here is 14 degrees. So to find out the angle going all the way around to that point, we are going to need to subtract 14 degrees from 180. Which will give me an answer of 166 degrees. So my two answers are x equals 14 degrees, and 166 degrees. Okay, in this example we've been asked to solve 4 cos x plus 3 equals 0. So when we're doing trig equations, my first bit of advice would always be to draw your cast diagram. And put in the values as well. This is 0, 90, 180, 270 and 360. We are now just going to solve this like we would normally any equation. So I'm going to first subtract 3 from both sides. So 4 cos x equals negative 3. And then I'm going to divide through it by 4. I'm going to get cos x equals negative 3/4. Okay, at this point I need to stop, I need to pause. And I need to decide which quadrants this answer corresponds to. So I want to know which quadrants cos of x would have a negative value, because cos x is negative. So I need to look at my cast diagram. In quadrant 1, all the trig functions are positive. So I'm looking for cos is negative, so we're not going to use this one. In quadrant 2, only sine is positive, the others are negative. So that means in quadrant 2, cos is negative. The same goes for quadrant 3. Okay, so we're going to be working within quadrant 2 and quadrant 3. Start off though, we need to find our acute angle. The thing that's different about finding our acute angle here is that we've got a negative involved. And when we're finding an acute angle, we drop the negative. We use the negative to identify the quadrants we'll be working in, but from then on we ignore it. Okay, so x equals the cos inverse, the shift cos of 3/4, which comes to 41.4 degrees. If we're just to do another sketch of our diagram, so we're going to be working in this quadrant and this quadrant, and our angles are always in relation to the horizontal line. It's going to be 41.4 degrees in here, and 41.4 degrees in here. And just remember to always put in your values here, 270 and 360. So the angles we are interested in is this first angle here, because we always read it in an anti-clockwise fashion, and then this second angle in here. Okay, so to find our related angles, so our related angles. So our angles are going to be in quadrant 2 and in quadrant 3. So in quadrant 2, we're expecting an answer to be in between 90 and 180. So I want to find that angle going from here to here. So to obtain that, I will need to subtract 41.4 from 180. Doing so will give me an answer of 130.6 degrees. Similarly, in quadrant 3, instead of subtracting from 180, this time I want to know the total distance beyond 180. So my answer is going to be in between 180 and 270. It's an extra 41 degrees onto this 180. So this time I'm going to add 41.4 to 180. And doing so would give me an answer of 221.4 degrees. Okay, so just make it very, very clear what your answers are. Therefore, x equals 138.6 degrees, and I'll just put a comma, and 221.4 degrees. Every other question is similar. You're either going to have a positive value or a negative value here. If it's negative, identify the quadrants where your function is negative, but then drop the negative and complete the rest of your questions just as seen here. The only thing we've not seen is if we have an answer in quadrant 4. If we have an answer in quadrant 4, for example, if our angle was in here, to obtain our answer, we would just simply subtract this given angle from 360 this time. This will come with a lot of practice, and the more practice you do, the more confident you should feel, because it should be, hopefully, quite a straightforward way to pick up some marks in your National 5 exam. Thank you.